Number 1A1, define power. So we must be able to know the definitions and be able to recycle them. So power is the work done per unit time. Of course, it can be written as power is the energy used per unit time. Power is the energy gained per unit time, or the rate of energy use, or the rate of doing work. So all of those are variations of the same definition. Work done per unit time. Now A2, use the definition of power to show that the SI base units of power are kgs meters squared per second. Now you must always understand and appreciate that what are SI base units? SI base units are the units of the SI base quantities. Now I don't want to explain what is a base quantity, but we just must be able to list all the SI base units. We have kgs. This is the SI base unit for mass. We have second, the SI base units for time. We have meter, the SI base units for length. We have amps, the SI base units for current. We have Kelvin, the SI base units for temperature. And then finally we have mole, the SI base unit for amount of substance. So we are looking for the definition. We are using the definition of power to find the SI base units of power in kgs meters squared per second cubed. So the definition of power that we have just written is power is equals to the work done per unit time. So understanding that it's work done over time, but work done is a force times distance moved in the direction of the force. So actually force times displacement of the body. That's work done. And then time, and then divided by time again. Then force, we need to find a formula that gives us force. Remember, we will be looking for formulas that could simplify where we start from things. That way we will be able to substitute the units in the SI base units. Force, a basic formula for force is mass times acceleration. So mass times acceleration times S, which is displacement, over time. But we also know something. We also know that now the unit SI base units of mass is kgs. So we substitute kgs. The SI base units of acceleration is meters per second squared. So we don't waste our time trying to look for the SI base units of acceleration from the definition of acceleration, since acceleration is something that we use a lot in kinematics. Then the SI base units for displacement is meters, and the SI base units for time is second. Now the next thing that follows is trying to manipulate and be able to join this statement here. Firstly, as you can see, as I have circled here, but I'm circling again in red, in green this time around, we have meter here and this meter here that are multiplying each other. So when this meter and this meter multiply each other, they give us this meter squared here. Then we have the kg, which remains kg here. Then the other thing is that we have a second here. We can say that the second is to the power of 1 at the denominator. Now using the indices rules here, I put two indices rules, this one and this one. But using the second one, this one, if we have 1 over x to the power of a, this can become x to the power of minus a. So that's what we did here. We brought this second to the power of 1 to become times second to the power of minus 1. So when this second to the power of minus 1 and this second to the power of minus 2 multiply each other, they give us this second to the power of minus 3. As a result, we have our final answer. We have proven what we wanted to prove. The next question asks us, the intensity I of a sound wave moving through a gas is given by I is equals to f squared a squared vk, where f is the frequency of the wave, a is the amplitude of the wave, v is the speed of the wave, k is a constant that depends on the gas. Determine the SI base units of k. So the question is asking us to find the SI base units of k. Whenever you have an equation, and in that equation you are being asked to find the SI base units of one of the letters in the equation or one of the symbols in the equation, what you do is you have to know the SI base units of everything else. So for intensity, for example, the definition of intensity is power over area, power per unit area, power arriving per unit area from waves. So that's intensity. But power, we already know the units from the previous question, which was kgs, meters squared per second cubed. Then divided by the SI base units for area, which we know that it's meter squared. So meter squared and meter squared on the numerator cancel out to give us the SI base unit for intensity. To find the SI base unit for frequency, we know that frequency from waves again, it's 1 over period. T, capital letter T is period. And then the SI base unit of period, since the time is second. So that becomes 1 over second. So 1 over second, when we raise that second, which is s to the power of 1 to the numerator, it becomes s to the power of minus 1, which is per second the same way. But since we want to know for the SI base units of f squared, frequency squared, f squared, so we then don't stop there. We just then come and say, okay, since f was per second, so f squared would be per second to the power of 2, which becomes s to the power of minus 2, like that. We also want to know the SI base units. We also want to know the SI base units, we also want to know the SI base units for, let's say, for meter squared. The SI base units for meter squared. For amplitude, sorry. The A here is amplitude, and if A is amplitude, we want to know the SI base units for amplitude squared. So the SI base units for amplitude squared then will be where there's A is in meters, so it's meters squared, like that. Then the SI base units of speed is meters per second. We know this, we don't need to waste time looking for that. Then we come here now, we make this equation, we make K subject of the formula here. So we've made K subject of the formula by dividing I by F squared, A squared, and V. When that happens, we know the SI base units of intensity is kgs per second, per second cubed. Then also we know that for frequency squared is s to the power of minus 2. For amplitude squared is meter squared. And when we do the math and everything, we cancel what must be cancelled. We are left with kgs over meters cubed. Then this becomes kgs per cubic meter, like that. So we have finished this question as it needed to be finished.